Good day and welcome. For this video, we will be having a simulation that tackles about astronomy and how it can how we can explore it in terms of utilizing what we have learned so far in physics, which is of course vectors. So vectors, as we know, is it's the first lesson, right? So it's a very fundamental, crucial concept that we have to learn before proceeding on the succeeding lessons on General Physics 1. And with this simulation, I want to showcase with you, then at the same time provide an instruction as well for our performance task, that the fundamentals of physics are deeply intertwined with one of the oldest sciences known to mankind, which is astronomy. So here we are in Stellarium Web. So you can find this by searching with the use of your favorite browser, Stellarium website. Then take a look at the site. It should be stellarium-web.org. Not this one. This is the software you have to install. This is a bit more technical. So we're going to have a very trimmed down version, which is this. Okay? So what I want to do is first explore, show you the features and what are the things that we can gain from learning physics, and maybe I don't know if you want to, let's say, try a citizen astronomy or take astronomy as a hobby, then you might as well want to do some astrometry, which is the measurement involved in astronomy. Okay, so first things that we want to do is to set up the site. So of course we want to set it up at full screen like this. Okay, then you click here at the upper left corner, view settings. You make sure that Milky Way and DSS are both checked. Okay, next you can now press the three horizontal button, which will close that left panel. All right, next what we're going to do is set up the time and the date. Okay, so let's do that. So I'm going to choose August 16. Okay, so there, let's set up the time at around 11:59. So the instruction for the time is located at our PETA instruction. So that will be the baseline of how we are going to set this up. Then you pause the time. Okay, so this is the time that I have chosen. Then this is the date that I have chosen. So you can choose the time anywhere between 7 p.m. to 4 a.m. As long as the sky is dark, it's okay. Okay, so we can close this one now. As you can see, the time is not moving. So we want it to pause so that our night sky will not move as we try to showcase and illustrate how we can use vectors in understanding astronomy. Next, let's choose the place. It's okay as long as it is in the Philippines. So for this one, I'm going to type, okay, so just for assurance, so let's choose Makati because that's where I live. Okay, so I'm going to choose this location. All right, and then let's drag this. Okay, so this is draggable, all right, by clicking the left mouse or dragging your screen. If you're using a touch device, you can drag this. Okay, take a look at the upper right. You can see the field of view. Okay, we can make it smaller by scrolling down on our mouse or whatever is the equivalent action to that. Pinch in, I think. As long as you can try to set the field of view to cover at least the whole circle, okay, or as long as you can see the whole circle is visible. It's okay. Whatever the field of view you have set is, okay. So for it might be different for any devices, so it's fine. Okay, so for this browser, the field of view to maximize the circle is 177 degrees. For others, it might be different. You just try. Okay? Then finally, we're going to click and unclick some of the uh, toggles here located at the bottom center. Okay, so we want to make sure that constellation is clicked, so it must be white and not gray. Next, the constellation art. If you want to explore some more, you can enable it. Okay, but I'm going to disable it for now so we would have less clutter. We want to disable the atmosphere so we could see pure deep black sky. Okay, and then we want to disable landscape so we could see, well, more of space really. Okay, and then finally we want to enable azimuthal grid. All right, so as you can see, it's now really starting to look like the Cartesian coordinate system, which you have learned from the previous discussion on General Physics 1. And then, of course, you enable the deep sky objects, okay? And then you disable night mode and everything else that we have disabled. It should be turned to gray, okay? All right, now, what I want to do first is explore. Let's try to explore. All right, so in learning the vectors or the topic about vectors, we have determined how important Cartesian plane coordinate system is. Okay, it enables us to determine the location or the position of certain points or certain vectors that are distributed along the space. Look at that. Have you seen that? It's a shooting star, right? Very interesting. It's the season of Perseids of around August, so it most probably a Perseid meteor shower. Okay, so going back, we have determined that angles are really crucial in determining the location in our vector space. And as you can see at the edge of our screen are labels of angles, or if we are going to disable the labels of constellations for a while, you're going to see the labels of the angles. So what we want to do now is to have 0 degrees located at the east or at the right side. So because that's the convention I have taught you. Okay, so for now, let's discard the cardinal direction indicated by Stellarium, as this is the convention used in astronomy. Okay, but for now, we're going to stick with angles, purely angles. So we won't be far off. Okay, so let's go back and return in enabling constellations. There, so we can now see the connecting the dots of the stars, much like how we connect the dots in learning vectors, right? So these stars, okay, so let's try to pick one. So let's say I'm going to pick something that is located somehow near the center. So let's say I'm going to choose Pegasus. So I think we're familiar with Pegasus. It's the winged horse in Greek mythology, right? So in space, we can measure the distance between. Wait, let's rotate that. So we can make sure that 0 degrees is located at the east. Okay, so this is 0, as you can see, because this is 15, right? So let's enable this back. Then I'm going to just drag this just a little bit. Wait, let's make it a bit smaller so it will be a bit more manageable. There. Oopsie. There. So let's try to pick some stars. So let's say I've picked Enif, and then I've picked the next star that is near to it, which is Biham. Okay, so this can be measured. In conventional physics, we use distance. Okay, so of course we can use it in astronomy as well. So we can use kilometers, and then 2 light years, and then 2 parsecs. Okay, so light years is a very large value. Okay, so if you are familiar with kilometers, 1 light second. Okay, so as for reference, so 1 light second is approximately 300,000 kilometers. Okay, or let's express it in terms of scientific notation, because that's what I've taught you with the review, right? So that's 3 times 10 raised to how many decimal places? 1, 2, 3, 4, 5. Okay? But of course, kilometers is not a base unit. It is kilo plus meter. So kilo is 1,000, diba? So that would be 3 times 10 raised to 5 times 10 raised to 3, right? So this will become 3 times 10 raised to 8 meters. Okay, but at least you're familiar with the value of 1 light second when converted to meters. Then of course, when you convert it to kilometers as well. So imagine this is the distance or the displacement covered by a single photon in 1 second. But of course, in space, it's not flat, right? So instead, what we use in determining the distance between 2 points, let's say 2 stars, if we want to determine 2 stars, is the use of angles. We call that angle of separation. So angle of separation can determine distance between 2 points. Okay, it can also determine size. We call it angular size, okay, of a celestial object. Okay, so let me give you a really good example to showcase this one. So we have Andromeda. There. Okay, so as you can see, you can kind of measure the distance by determining the points here and here. Okay, so by drawing imaginary points there, and then of course working your way by using trigonometry, you can set up 2 lines here. Okay, and then determine the hypotenuse, which gives you equivalent value. Of course, that has a unit of degrees, or we can just call it units. Okay, you're going to see that in your PETA, that we're calling angular distances in terms of units. Okay, so there's that. So let's go back to our previous orientation. So there. Did you know that zodiacs are actually constellations? Okay, so all of them can be seen through the night sky. So if we want to see all of them, so let's take a look at those we can see here. So we have Aquarius, we have Capricornus or Capricorn. Okay, if we're going to move this, you're going to see the other constellation. So you have here Sagittarius. Okay, or let's move a bit to this side so you can see them. There, so we have Sagittarius, then we have Scorpius. All right, what else? We have Libra, we have Virgo. Okay, so maybe you want to pick for your PETA, which of course is okay, a constellation that is very close to your birthday. or let's say your zodiac sign, you can definitely choose that. And maybe you might be able to find some interesting uh, objects that we can find inside those constellations. Okay? Let's have an example here, a very interesting one. So let's say we have Cancer. So Cancer is can be seen during the day of August, but that's okay. So you can see here we have this highlighted area. So this is for ACP. Okay, if you're going to look at the upper left, you're going to know other information about it. So it's also known as the Beehive cluster. So as you can see, there's a lump of stars that are clumped together in this particular space. Okay, so another great star cluster is the Hercules globular cluster. So if you use the search button here, or I mean the search area here on the top center, so you're going to see this, okay, also known as M13. So that's the Hercules globular cluster. Okay, so going back, constellations are useful tools for navigations. For, like, let's say you want to determine your location on Earth just by knowing the time and knowing the constellation above you. So you can definitely do that because constellation appears. That's why we input location on our Stellarium web, because as you move up on the Earth's latitude, the constellation that shows up in the night sky changes differently. So what you can see on the northern hemisphere will be different on those that you can see on the southern hemisphere, something like that. Okay? Okay, so let's say your zodiac sign is Leo. Okay, so let's go to Leo, the constellation. There, we can see the boundary if you search for the constellation. So as you can see, if we zoom in, it might look like there's not much. Okay, but if you try to explore, you'll be able to see some interesting things here in the Leo boundary. So I'm just trying to look for them so I could show it to you here. See, it's not located at the lines of Leo the lion, but it is located inside the boundary of Leo, which is this. Okay, so let's zoom at those again. So as you can see, these are what we call as the Leo triplet. So these are all galaxies. So this is M66, this is M65, then this is NGC 3628. Something like that. Okay, so there you go. You can try to, I don't know, if you want to experiment or something, you can try to take a screen cap. After all, that's what you're going to do on your activity anyway. So you can try to take a screen cap and then you open Microsoft Whiteboard, for example, or any whiteboard software, and then you can use ruler to measure or to just put some ticks. Okay, just of course remember your field of view, and then you can standardize the number of ticks that you can have. So this is, for example, what we call, if you're going to draw a line here. Okay, so this will be what we call as the angular separation. Okay, now I guess we can now take a look at the instruction of the PETA, so we could have grasp on what we are trying to accomplish. I'm going to revert this time now to 11:59. So there. Okay, so and then let's go back a bit further there. So we can see more of the night sky, right? So let's take a look at the instruction of the PETA. Okay, so for this case, it is set to 138 degrees, but as you can see in my browser of choice, to fully encapsulate the circle, we have set it to 161 degrees. So it's okay as long as what you want to capture is within the field of view. Then at the same time, you can see the azimuthal grid, which is very similar to Cartesian coordinate system, is set up like this. Okay? So according to the instruction, we want to choose 10 constellations. Okay, so what I've said earlier, you can choose, let's say the zodiac, your zodiac sign, or you can choose any familiar constellation to you, or maybe you might know a character from the Greek mythology that is a constellation as well. Okay, so we have Andromeda, we have Perseus, we have Cassiopeia, we have Hercules. Okay, so you can try to look for those. Okay, and then choose those as your constellations and place their name here on this table. Okay, so what we want to do is pick 10 constellation, and then we want to explore each of these objects. So we have 4. Okay, so we want to pick at least one per each constellation. So let's say an alpha star. So what's an alpha star, sir? So alpha star is the brightest star of the constellations. So whenever we look at the night sky and we see very bright star in this polluted city like the Metro Manila, you might be seeing a very bright alpha star. So let's say in the case of Lyra, the lyre. So this is one of the recognizable constellation in the night sky because the alpha star Vega is very very bright. Okay, so during the season when you can still photograph this constellation, you're going to see Vega a lot every night because it's really bright. So it's alpha star. So denoting it alpha, so you can see it here. There's that. All right, so you can choose that. Next one will be a nebula. So a nebula is a cloud of dust, also known as stellar nursery. So it is a place where stars are born. So one of the most famous nebula is Orion Nebula. Okay, so we can take a look at it. So you can see. So there, it is located at the constellation Orion. Okay, so here's the boundary of the Orion constellation. Here is Orion Nebula. Okay, so if you zoom it in, you're going to see a very cloudy appearance, which is very, very popular to astronomers. So if you want to try, actually you can see this very prominent on December night sky or the winter night sky. So December, January, February, around the time 7, well, until before midnight, I guess. You can photograph this as early as, well, as early as now, but this is still very low on the horizon. So you can wait for winter to come and to photograph this magnificent nebula. So there. So that's another example. Then you can have a galaxy. Okay, so a galaxy that I want is, let's say, the one that we have an example there. So we have Andromeda. There. So this is Andromeda Galaxy. Okay. So very much like the Milky Way, it is home to hundred thousands of stars, which of course might host life. All right. So, and then lastly, we have star clusters, which I have demoed earlier. So what we're going to do, sir, so let's try to do a demonstration and I'm going to show you how. So I'm going to pick this first entry on the table. So this example will be visible on your performance task sheet as well. Okay, so let's try to zoom out and then set that 0 degrees is located at the east there. So let's search Andromeda. There. So Andromeda is this boundary and of course this constellation. What we want to look for is Andromeda Galaxy or M31. There. So what we're going to do is make sure that you have selected the object. You can confirm it if this appeared. By the way, it's a misnomer. All right. We named it Nebula before because we thought that Milky Way galaxy is only the galaxy that there is. Then we have discovered that Andromeda is actually a galaxy, which shattered the idea that Milky Way is the only universe that there is. Okay, so it's actually a galaxy. All right, so if you zoom out and then set the like that, for example. So where's 0? It's on the other side. Where is it? There. So let's check the time. Let's check the place. Okay, so now where is Andromeda located? So it is located at the first quadrant. Okay, so this is basically a way for you to be accustomed on locating points and determining the rough angle, then at the same time in which quadrant it will fall. Okay, so it's fine if you're going to round off, it's okay. Okay, so I have placed it in the instruction. Now it's okay if you're going to round off the angle. All right, so where is it? So you can see the angle is between 45 degrees and 60, but it is nearer to 45 degrees. Maybe we can zoom in on that. Okay, so is it still moving? There. So let's just try to. There, it's still very close to 45, so maybe just 46. Oh, you can see here, oh, still 45. Right? So we can now zoom out again and place it like this because this is 0 degrees. So quadrant 1, 46 degrees. Okay, something like that. Oh, let's take a look at another example. So we're going to search for constellation Capricornus. Okay, so Capricorn, I think it's the goat, right? So let's try to zoom in. Okay, so this is the alpha star Algety. There. So as for our example, this is the object that we're going to determine the angle. Okay, so the angle of location in reference to the coordinate system. There. So it is between 225 and what angle is this? 210. So as you can see, this is 210 degrees. This is 225 degrees. So it's somewhere in the middle kinda, but it's a bit nearer to 225 degrees. So you can zoom a bit more to this one. So it's still kinda in the middle, but we know that it's nearer to 225. So you take the middle of 210 and 225. So what's the middle of it? So 10, 25, 15. So that's 7.5, right? So 217.5. Then it's a bit nearer to 225. So maybe around 219, 200. Oh, there, 217. Okay, 218. It's okay. All right. Then you can zoom out. Make sure that you have placed the 0 degrees at the east. Okay, and then there. That's it. So how am I going to determine uh if you did the exercise? Of course, you're going to take a screenshot. Okay, so this is an example of the Andromeda Galaxy. Okay, so you can take a screenshot by, if you're using a Windows device, print screen. Okay, or my preference, Win Shift S. So I'm going to show you that. Oops. Win Shift S. There. So drag the whole screen. Then that's it. You have captured the screen, and then you can paste it on MS Word. Okay. So in this case, I'm not going to do that because we already have Algedi here. Okay. So there. All right. So hopefully you were able to, I don't know, enjoy the simulation in a sense. Try to work it on by yourselves. Try to explore just what I have said. Use or search Messier objects and use that as a reference in searching for objects. You will really find a lot of interesting things, a lot of really wondrous, awe-inspiring, jaw-dropping things, right? Objects, celestial objects. Okay, so there. All right, at least you'd know that uh, in doing astronomy, which is the oldest science, uh, we have utilized the most fundamental, one of the most fundamental skills in physics, which is determining, well, basically the distance between 2 points. Okay, so that's, of course, distance, and then knowing, let's say, drawing how you move from point A to point B. Let's say, from this example, let's say there's this study that can define the movement of the object from, let's say, this galaxy going to this galaxy. Then let's say you want to expand on that, and or just, let's say, you want to just determine how to slew your brand new telescope. So you want to know how long or what should be the directions you should take in slewing your telescope. Let's say you pointed it to Galaxy A, which is NGC 3628, to Galaxy B, which is M66, to Galaxy C, which is this one, M65. Okay, so you can express it, well, you're going to see it in PETA in part 2, that it is expressed in units. Okay, so we're going to call, or we're going to assign the unit for distance or the angle of separation as units. Okay, so there. Okay, so vector points, it can be a star, it can be a way to measure the distance between, let's say, the moon. Okay, so if you're familiar with these two, and then you're familiar with the tick marks that you have utilized, you can kind of surmise the value of each ticks in terms of degrees. Okay, or in terms of units. We call it units because, of course, the night sky is really not a flat space. All right, it is actually very, very broad or very big three-dimensional thing. Okay, it's not a flat sphere. No, it goes beyond. It has depth, and you can travel through it. But of course, when we're observing in the night sky, they look like it looks flat. right? So in order for us to have a handy way of measuring the distance between them, we use, of course, flat objects and kind of convert it into spherical trigonometry. But for now, uh, determining distance in terms of angular separation just by using rulers and, of course, the knowledge of angles is well enough already. Okay, so there you go. I hope you will be able to explore more. You might find some more interesting things in your constellations of choice. Thank you and may all have a good day.